I'm Prakashan Korambath. I work at UCLA Office of Advanced Research Computing and SESMI, the Smart Manufacturing Institute that UCLA runs for Department of Energy. That's a $180 million institute to research into the smart manufacturing for the US manufacturers. So today I'm going to talk in 10 minutes the history of large language model from 1950 to 2025 and how much it changed. That whether you call machine learning or artificial intelligence or everything, the large language model started with this concept that if you have a sentence like, I arrived at the bank after crossing the river road, the human beings have no issue finding out whether this bank refers to a river bank or financial bank, but artificial intelligence could not do that. And in the 1950s, at the height of Cold War, the Western government wants to translate Russian language into English language, right? So they found English language itself is ambiguous, right? So most people did not think that computers can translate this at that time. And look at the next thing. Mary saw the bicycle through the store window, and she wanted it. Now it refers to the bicycle. And she looked at it longingly through the store window and passed her nose against it. So saying it previously referred to the bicycle, now refers to the window in the simple sentence, right? So this was considered an impossible task at 1950 for a lot of people, but not for Alan Turing, which most of you already know that Alan Turing was capable of breaking codes, and he had a lot of credibility. He's considered as the father of modern computational science, and he laid the foundation for the thing, right? So Alan Turing didn't want to address that intelligence problem. He instead translated that into a language problem. He said that in the paper, Can Machines Think? He said that if a judge sits there and if he does not know in a closed door whether it's a human or machine, and if he gets the result same, then we have the artificial intelligence. So he gave some 50 years to figure out that thing, but within 75 years, now we know that with the transformer model, we can also do that. So this is an example. There a judge sits, and in the closed door, the judge does not know whom he is talking that. And if the results come back the same from the human or anything, now we have the artificial intelligence. That is called the Turing test. Here there is a timeline of how the things happened since 1950. So 1950, Turing placed the language at the center of intelligence. That is the basis for large language model. And now we are talking about artificial intelligence in the language. It was because Alan Turing started at that stage. And in 1956, in the Dartmouth conference, and it is very important for Los Angeles people, and at least 5 of the people who presented at that conference, they were from Los Angeles, because at that time in the 50s, Los Angeles was big time in aerospace industries, right? Now we ceded that to San Francisco, so now we had to bring back to that, to Los Angeles. And after 1950s to 60s, there was a AI winter period that nothing happens, right? Because we didn't have any computational resource or anything. And only it started after 1918s with the recurrent neural networks and 2014 seek-to-seek learning and then attention mechanism, right? When people talk about the transformers, you talk about decoders, encoders, its original beginning, it has it in the recurrent neural networks, right? But the recurrent neural network is similar to the feed-forward networks. In the morning, we have seen all the artificial neural networks, but it has an additional capability of remembering the previous word and then passed on to the next word, like a hand holding. But it could not have solved that previous sentence. I showed you that the river bank thing, because the bank was further away from the river or road, right? It could not solve a long sentence. But it's a small sentence, recurrent neural network could solve it because it's a time series problem, right? Then we know that transformer architecture in 2017 solved this problem through Q is equal to KV, that attention score values. So this is kind of a timeline of artificial intelligence. Now, because of the way the decoder creates a token, the LLM has limitations, right? So in my talk, I'm going to talk about the agents. LLMs create the tokens in autoregressive model. What is autoregressive model? It comes out the first token, it analyzes sequence word to estimate the probability, and that the next token comes afterwards that. So if you get the first token wrong, it is like that if you take the first lie, in order to cover up that, you have to give a lot of lies, right? So if your first token is wrong, every token that comes after is wrong, going to be wrong, and that is the basis of hallucination. And LLM has no feedback loop, that once it generates a token, it has no control of correcting it, and it cannot do any actionable power. It cannot book a flight. It can tell you about all the flight details. It cannot actually go to a website and book, but the AI agents can do that. And there is a knowledge cutoff, right? The day it was released, it does not know anything about anything after that. If you ask the yesterday's basketball game or baseball game, it does not know that. But AI agents can know that. And it also has a context window limit, which agents also has it, and it does not have a long-term memory as well. So what are the difference between the AI agents and the LLMs, right? LLMs are text only, but we know that there is a multimodal thing that can analyze the visual. But the agent AI, it can gather data from the API sensors. If you have a temperature sensor, if you have access to the web page, it can go there and see whether who won yesterday's basketball game and report to you back that. LLM cannot do that by itself. It needs the agentic AI capability to do that. And it's reasonable style. LLM is linguistic, and the multimodal, you can see the videos and audios. And in the agentic AI, it can think and act just like the way human beings do. Just like we have eyes and ears and hands, agentic AI has all those capabilities. And it can, the LLM cannot do any action. It can only tell you what it is. But agentic AI has the Python tools, browsers, API. It can actually go along the browsers and click the links for you. And LLM does not have any error handling, and it's very passive, but agentic AI is very, very active. Okay. And this is an agentic AI loop where the user query comes, and then it does the reasoning part, it does the planning, it decomposes the problem into simple problems, and it makes a started learning, and then it goes through the tools here. And the tools are the web search, email, code interpreter, everything that we have to provide to that. So since I'm running out of time, I will give you how the agentic AI actually works. That when the user comes to the query here, it go to that query start, and user asks a question, what is the weather in Los Angeles now? And the LLM, of course, does not know the weather in Los Angeles. But as we programmers, we have provided the LLM with a function that can call all the weather API. And then the LLM asks that, did the programmer give me that function? And if it is yes, it goes through that loop and call that weather API and put the output of that back into the context window, and then LLM gives you the answer saying that, okay, Los Angeles weather is 68 degrees now, and the humidity is this thing. That's how agentic AI works, and that result is accurate because we wrote the code and we called the real website to get the real data. That's why agentic AI, you can actually put it in production because it does not hallucinate. And this is a little bit of details about how agentic AI works. This is mostly for the programmers, right? So if you have to write it, everything works in a JSON schema where you have to provide a function name. It can, like get current weather or search web. You cannot duplicate that. The most important part is the detailed description of what that function do. So when users query, the agentic AI looks at whether I have that the function to give that answer. Then it calls the answer. Then there are some requirements, the parameter name, data types, and constraint. So, then it calls that function. These functions were introduced in late 2023 by OpenAI. Now it is available in all the models, whether you use the Gemini, Anthropic, or anything. So this is a little more detailed about the sausage making behind what is happening. This is more for students and programmers. This is how you write it, and this will call the program and run, and they have the orchestrator, validation, observation. So the orchestrator, when the question comes, orchestrator is the one which is planning everything. LLM is not involved at that stage. It calls the functions and get the result back and put it into this thing. Now, since more models have different APIs, the model context protocol came in. That's the USB-C of all the agents. So you have a single function called tools that can work with any of the models, and you just have to write that MCP part and make the MCP server and expose it to anybody. Anybody in the world can call that server, the functions you wrote, and you are not paying for the token. Only the client who are calling, they have the LLM, and they will pay for the tokens, and they will make it available. So with these things, Agentic AI has eliminated the problem of hallucination, and now you can deploy AI in any production system, because the agentic part, you wrote it and you know where the result is coming, and you're putting back the result into the context window. So now I think I'm out of time, right?
Yes.
Okay.
Any questions?